A couple plans to have 3 children. What is the probability that they have all boys and they have at least one girl? Okay, starting with the first. So the probability of all boys. So that would be the same thing as saying, what's the probability that the first child is a boy and the second child is a boy and the third child is a boy? So all of those ands joining our events together tell us to multiply events. But before we go and multiply events, we have to make sure we're dealing with independent events or dependent events, so we know if we need to decrease our probabilities from one stage to the next. Here we have I think the only thing we can really do is assume independence, even though we don't have a large population. And honestly, even though this is one couple, which you could actually think that there might be some biological component which says that each couple could be more likely to have more boys than girls, but let's keep things simple in probability and statistics. Let's just assume the probability of having a boy is 50%, and the probability of having a girl is also 50%. So we'll keep it simple like that. All right, so the probability of all boys. So 50% is the probability that the first child is a boy. And 50% is the probability that the second child is a boy. And 50% is the probability of the third child. So assuming independence, it's 0.5 to the third power, which would be 0.125. What's the probability they have at least one girl? So at least one girl. There's different ways that you could potentially think about this. So one way that I have students trying this problem is to do something like, all right, well, the probability of a girl is 0.5, probability of a boy is 0.5, and the probability of another boy is 0.5. So I have one girl here and then 2 boys. So that's at least one girl, so that should be my probability. Now, recognize I wrote this in red because it's wrong. The way we have to think about this is we have to think of this as the probability of at least one is 1 minus, oh, that's odd, thought I switched to the blue pen. The probability of at least one is 1 minus the probability of none. So we need to figure out what's the probability of having none, which in this case would be none of the 3 are girls. Okay. So the probability that none of the 3 are girls would be the probability that the first one is a boy, the probability that the second one is a boy, and the probability that the third one is a boy. So that's what we came up with in part A. So the probability that they are all boys. So the probability that they are all boys, probability that none of them are girls, that's the same thing. So 1 minus 0.125 then is 0.875.